At the very beginning of this chapter, we learned that there are four main principles in OOP. In this tutorial, we'll learn about that third principle we talked about, which was inheritance. Inheritance allows us to define classes which inherit most of the properties of already existing classes and which can be used in all aspects in which the existing classes can be used. So that might sound a little confusing, but basically to apply that into a real life example, we're going to have we're going to define a class called vehicle. And then we're going to have later on, you're going to see a class called car. So logically, a car is a vehicle, and a car has all the attributes a vehicle has. So it inherits the attributes of a vehicle, which you'll see as I type out this example. And the fourth concept is closely related to inheritance, which is polymorphism. But polymorphism is the ability of an object to adapt to the type of data it is processing. So you'll see that later on. It'll be more clear in the example. So let me just jump right in. Let's just dive right in it right here. So we're gonna define our vehicle class. So we're gonna have the constructor method. Here we go, self. So here we go, self, VIN. We're gonna have a couple attributes here, manufacturer. So you'll see in the car class, you'll have these similar attributes, but you'll have other ones added on because what this is going to turn out to be, the vehicle class is actually a base class, which is also it's also called an abstract class. And all base class methods are virtual and can be overridden in the inherited class, and we'll demonstrate overriding with the method vehicle type, which you'll see just in a sec. You'll see that in a little bit. So let me just type this out. So we have VIN, we have self dot weight equals weight. Then we have lastly we got manufacturer equals manufacturer. We're also going to have our getters for the vehicle class. So get weight self return. So basically you define your constructor method, then you define the getters, and if you have any setters, you define those as well, but they should it depends on what your class is being used for. All right, so we have self.weight. We're going to define get manufacturer, yeah, with the attribute self, and return excuse me, self.manu. There we go. And now we're going to have this vehicle type, which is going to be overridden by our car class. So let's do that vehicle type, self. And then we're going to say just pass. All right, so moving on. Now we're going to, so this is our base class or our abstract class. And it's going to, well, let me just write out the car class, which is going to inherit attributes of the vehicle class because a car is a vehicle. So here we go. In the parentheses, you see vehicle being, that's the inherited class. So def init, we're having our constructor method again, but this time for car, oops, self VIN. So Sublime Text has an autocomplete feature, which is really handy for situations like this. Kind of saves time in typing all this out. So, but now we're gonna have our seats. We're gonna have a seat attribute, and as you can, that's not in vehicle, but it's in car. So, class that inherit from an abstract class can basically have their own attributes. But you can't really have vice versa because it wouldn't be inheritance then. All right, so VIN self dot weight equals weight self dot. Now we have a seats. It's not self seats equals seats, and we're gonna have self. What's our last one? Manufacturer, right? Manufacturer equals manufacturer. So, all right, let me just clear that off. All right, so now we have our constructor method. Now we're going to define some getters. So here, if you notice here, I'm not naming it get seats because this might reflect an actual real application of this class's method in real life. Or yeah, that was kind of redundant, but whatever. So yeah, I just named it number of seats instead of get seats because it might reflect a real life application. So def, and we have vehicle type now, which you'll see is going to be overridden, which is going to, it's now going to be car. Return, now it's going to say car. And now we're going to do the same, we're going to apply the same sort of situation. I'm just going to copy this and change a few things. So, because truck is pretty similar, but instead of seats, we're going to have an attribute called capacity. So instead of seats, capacity, there we go. I'm kind of taking a shortcut instead of typing it all out, but this saves time. So instead of number of seats, we're going to say transport capacity. And we're going to say return capacity. There we go. And the type now is truck. So this example demonstrates inheritance. As you can see, I keep repeating myself, but it kind of helps me memorize it, that we have inherited attributes. These are also found in the base class, the vehicle class. And now we're going to go ahead and demonstrate polymorphism. So we're going to demonstrate this through mechanisms of virtual methods in which we will use fictive values of attributes for testing purposes. All right, so let's do that. So a car. So we're gonna have a car. We have an instance of the class car, and so we're gonna have it's gonna have the attributes ABC 1000, and it's gonna be a BMW, and it's gonna have seats 4. Then we're gonna have one on a truck now, class instance of a truck. It's going to have BCD 2, and it's going to have excuse me, one attribute 1000. It's going to be a man. It's going to be and the capacity 10,000. Next, we're going to have C. See, these are just random examples. They're not real life examples, but in a real life application, they should actually reflect real life things, objects. All right, DEF3, 1200, and a Ford. It's gonna have 4 seats. D. It's gonna be a truck. EFG 4, gonna have 11,000 for the weight. It's gonna be a Mercedes, and then have 15,000 capacity. All right. So now let's test the implemented classes. So we're gonna have print, and then we're gonna have a dot. It's gonna have autofill now with get weight. That means everything checks out. Everything is all good in A. Same thing goes for B, and we're gonna get the manufacturer of B. There we go. And then we're gonna have, we're gonna have the now we're gonna have, what are we gonna have next? Okay, so for C, we're gonna get the number of seats. And for D, we're going to get the transport capacity. There we go. So we're going to test this out, and truck is not defined. Hold on a sec. Silly me, I forgot to change the class name, truck. Whoops. There we go. So that pretty much checks out. And now we're going to see a polymorphism, which is going to look like this. So we're going to have we're going to have a for loop now. So for v in sequence A, B, C, and D, and we're going to print out the following. We're going to print out for A, B, C, and D, we're going to print out we're going to get the manufacturer, And we're also going to get the vehicle type. And that works out. And this last line is from before, so let's erase that. There we go. And there's our answer. So, and at this point, we have demonstrated most of the concepts of object-oriented OOP, object-oriented OOP, object-oriented programming in Python.